All right, thank you very much for staying. I know I'm the last person between you and the bear market, so that's always a tough one to deal with, but we'll get through it. Sage words of advice from Robin. Pay attention to what you're learning. You never know what's going to happen to you after your education in cartography. So when I was a student many years ago, the exact same academic program for the summer, my summer internship, is the one that I'm now managing. So at least I kind of understand and paid attention to the things that I needed to do to prepare my students to go on that one. Also, your eyes are better when you're 20 than 40. Think about that in terms of cartography. So I'm Jay Ware. I teach at the United States Military Academy. And the project that I worked on, I did some research over like the last 18 months on really how do you teach cartography? So I was kind of charged with looking at this. How do you take information and portray it how it needs to be portrayed? And so one of my research folks I was working with kind of challenged me to go, well, look at it from a traditional lecture as well as from an online lecture and do some comparisons. Also get into kind of motivation of students. So I looked at some of the behavioral factors as well. And it kind of pushed me into a little bit of different research area than I was kind of accustomed to in the geospatial information science. And I found some interesting things. And again, it was a really fun project to work on. And so it was really to determine, okay, is there really a big difference between online content and a traditional lecture? And that debate continues, and some feel strongly one way or the other, but let's kind of look at it from a research standpoint and develop some methodologies and try to figure out what works best in either domain. And so my objective was to really figure that out. Now, I really kind of honed in on just the generalization techniques, because that's something that's pretty common in a cartography course, which I'm teaching now. And I also had access to plenty of research from the past, the lectures I present, lectures other people present, test scores. So I had a lot of good evidence that I would be able to pull into the research. And what I really found that worked was it was really more the content, not so much the method of delivery or the mode of delivery, and pretty much the same whether it was online or traditional. But one thing also was that collaboration matters. And I think that's kind of changed over the years, because from a kind of a manual cartography standpoint, you can kind of sit behind a desk, kind of work on things. But it's actually a whole lot more collaborative now because of just how things are changing, whether it's sharing code and software, whether it's sharing the ideas. And so that's kind of one thing I observed in the students. It's a lot more collaborative than I initially expected. And that also lends itself to actually using different types of techniques. And so what I really wanted to know is why do people sign up for my course in the first place? And what do the students really want to learn about cartography? And then how do they best learn it? And then how do they apply it? And so kind of that prevailing thought was really sitting in a classroom, talking with people is how you share ideas. I agree with that, but you can also do that in a lot of ways. We can talk on the phone, we can chat on a computer. So I think we were missing a little bit of that, and kind of going into the research, I wanted to kind of clarify some of that information. And it was also figuring out what do you actually need as a baseline knowledge to start working on generalization techniques. Whether you're doing it manually, whether you're conducting those on a specific software package, is what does a student need to know before they can kind of go to the next advanced level, so they get that higher order of understanding. And so really it's kind of like my method was kind of let's talk about maps, let's learn how to make them, and let's make them. So we go from kind of this theoretical underpinnings to actually creating products. And one thing that was kind of interesting that I found was with the course objectives, which are kind of up here, is what do you want to learn as a student? And overwhelmingly it was, I want to learn how to make maps. So it wasn't really, do you want to learn, the theoretical ideas behind certain cartographic techniques? It was, no, I signed up to the class to make maps. So I was like, okay, that was kind of where I wanted to take this further. And it's interesting to get that feedback from the students. It's also an inquiry-based course. The software that we use is Esri's ArcGIS, although we have other software packages that are available to us. And so what I normally do with the lectures, particularly last year, was you present a lecture, then they go work on a lab exercise. It kind of lent itself to some change because we're moving from a 55-minute format to a 75-minute format at our institution this year, and I'm test bedding that this semester. And so I've kind of like walked back on the lectures and a little bit more on the actual applications. And so I wanted to see how that worked specifically for this lecture that I had for cartographic generalization techniques. And so as we're kind of moving digitally, it got me to thinking a little bit more about what do we need to do online and how do we share that information. Now, our population of students is a little bit different. They're all 18 to 22, so we don't have anybody coming in that's over that particular age, and it's a kind of a finite population, but it's like you still learn the same way. And so I wanted to figure out what were the motives that people wanted to learn about cartography, or what brought them into the classroom, and then how did they best learn this information, whether it was in 2 dimensions or 3, online or in a traditional lecture. And then how could we look at this and draw some conclusions from it. And so was cartography easier, can it be taught easier in one domain or the other? And the research kind of shows kind of really doesn't matter. It's more about the content than the delivery itself. And it just happened to be the course I was teaching, so I had access to a lot of that information. So in terms of the background, kind of how I wanted to go in towards the methodology, was really I already had access to kind of some previous lectures. I made some changes to some lab exercises. The students have a group project where they work together, bring all those principles together, and then their final project is they work on their own and then implement some of these cartographic techniques. And then I grade them based off of which ones they use and how well they've used them for their final product. I even have 2 of my students there from last semester. I also have a kind of a competition where they produce them. I have some people kind of vote on it and figure that, they say which one of these is best, kind of like we do in the mapping as well. To add a little bit of competition to it and get them working on those products. Really, my methodology was simple. I came up with my hypothesis is there's absolutely no difference. Now, did I believe that initially? No, because again, we all have our own biases about whether we like to get up in front of people and speak and whether people actually listen to us and absorb the information, or I can sit behind a computer, or I can read a book and gain that information. So, but I did set up my little hypothesis as there really wasn't too much of a difference. The other thing was all the information was anonymous and non-attributional, because I actually had to do an IRB for the study, and I wanted to keep it as unbiased as I possibly could. So the other thing that I kind of explored with this was some of the research was talking about whether or not someone would teach something based off their grasp of the software. And sometimes those of you who've been in the field for a little bit or a long time know that some of the software there's kind of a high startup cost. And so if you're if you're teaching this for a long time, you kind of get comfortable with the things that you like to teach as software versions change. So I wanted to look at it and see, okay, is there some way that we're not teaching the techniques as best we can because those who are teaching aren't learning the software or keeping up to date? And so I kind of explored that. I didn't find that was too big of an issue, particularly in the digital domain, but there are still some pieces of academic literature that still kind of crop up in most cartography courses that I found across the board. So the results? Really, what I found was the students like kind of a mix of information. Again, doesn't really matter whether it's delivered online or traditional, but the key thing is making sure that that mix of information shows what is being demonstrated in those generalization techniques. And so kind of an example would be having a kind of a non-interactive sort of animation along with the text. So you could actually see the animation, then go back and read the text and make sure you learn that information. And there's a lot of reasons for that. Someone might have missed the lecture, they can go back and review the information. But I kind of found also that with it, the interest in the subject matter, because I was asked to kind of explore that as well, was, as you kind of see it down at the bottom right, was really didn't change too much. I think most students preferred the fact that they could actually be in a class where they could ask questions, and that was kind of the key part to it was, if I don't understand something, is there some person I can go to that's an expert and ask the question? And I think that's important whether it's in a kind of traditional classroom or online, is access to that person or group of people that can help you out with that. But the interesting part was it didn't decrease that much with most of the students. So again, I initially thought people would kind of shy away from the online, but I actually found they actually preferred it in some instances. And they actually learned quite a bit from that. In terms of the results, simplification followed by merging were the 2 most useful techniques, particularly in the class and the final project. The other thing about merging I found was I asked another question is, what's the most difficult one to learn? And most people said merging, but that was actually used quite a bit in the final project as well. So they didn't shy away from something that was very difficult, they actually embraced it and tried to apply that to their projects. And again, kind of mapping. I want to take a cartography course to learn mapping. And then also, the block did challenge them to use thematic maps. So I looked at how many of these techniques were used, and interestingly enough, most students actually tried to apply these in their final project. So it wasn't just like I pick one or two and try to get my grade. It was like actually they tried and explored these different techniques. So that was encouraging to me as an educator. And then how did they find it most useful was another question that I asked later. And it usually came down to one specific aspect of what they chose for their project and which technique made the most sense to what they were doing. Now, in terms of 2D or 3D formats, this was an interesting one. And so I kind of came at this thinking, okay, in this digital age, we're used to using our phones, we're used to kind of looking at things on the computer, most of the younger students are going to gravitate towards 3D. That really wasn't the case. Again, it kind of went back to, do I understand the information that I'm being given, again, regardless of delivery mode, and then how can I use that information to actually learn from it? I also found that if you're not really accustomed to 3D animations, they can be daunting. And those of you who kind of work with some interactive software or had to take like online classes where there's a lot of interaction, I personally find them very difficult to kind of navigate through until you get used to it and then you're okay. But think of it in an introductory cartography course where you may not have been exposed to some of these things in the past. It's a pretty big, hump to get over to be able to learn those techniques. And so what I ended up finding was that there's some motor skills that are involved in this as well, typing on a keyboard, but most of the students now are pretty accustomed to this, so it's not too big of a deal or too big of a leap. What I found is if you're not used to understanding how that technique can be extrapolated, you're taking 3 dimensions, putting it in 2, and then back into 3, there's a lot of processes that are involved in that. But again, in terms of a preference is, most people would prefer 3D over 2D if you just ask them that, but it really came down to what's the content that's being delivered and does it actually contribute to learning overall. So most of you have probably seen this, kind of a typical way that we look at providing information, kind of textual information with the definitions of the cartographic techniques, or kind of the ubiquitous slide there at the bottom is how we display that in 2D. But the kind of key thing I was looking at is how do we get from teaching this kind of 2D way going straight 3D to 3D. And so here's a couple of products that some of the students created in our courses, and it's really taking information that they collected from drones kind of in the bottom in 3D flying around the campus area, and then taking that information and going straight to kind of a topographic map that you see on the right, and then also taking a digital elevation model and creating information from that. So combining some remote sensing and GIS to create these types of products, because that's what we really want to get to. We want to get to representing the Earth as close as we can to what it really is at the appropriate scale. And so with learning effectiveness, again, kind of is the instructor available to facilitate that, and we make sure that that occurs. And also, it's kind of the one thing I also wanted to look at is if someone misses a class, and that's kind of important. So we do have students that are routinely out of class for academic conferences or athletic participation. So I didn't want them to get behind because it's a computer-driven class. They come to a classroom, and yeah, we can load the software up on their laptops and they can take it with them. But it's really being able to access the information and continue to learn those processes. And so found that was fairly important to the students is they didn't want to get behind, but they also wanted to be able to have the text information there to read through it and then be able to pick up on that information. Also, looking at optimal formats, I'd initially looked at, is there kind of a way we could blend these processes together, but I figured that's probably future work in the long term. But one of the things that was really kind of having that live webinar format may be an optimal format because you got to get a mix of all the things that kind of research-wise showed up as important to the students to learn cartographic techniques. And you also have an instructor or a facilitator there to answer the questions. So I think there's a little bit more research to be done in this area, but I think that's probably one of the more optimal ways to explore this. And so looking at going from that 2 dimensions to 3 dimensions is kind of a technique here is we can kind of show this on a page with some block diagrams and expect someone to be able to figure out that those 5 blocks follow a process that becomes 1 block. But it's really, why don't we show someone what an actual piece of ground looks like with the features, and then come up with a consistent symbology that kind of makes sense to our brain and do that. And so instead of going into like a kind of a huge, labor-intensive 3D interactive model, what I found was something simple along these lines probably meets the intent for what most students would need. So you got the text, you got kind of a simple animation, break this down in terms of aggregation, and then you have a basic explanation of what this process does. And so this is what I'm kind of moving to with some of the lecture slides that I'm building. It also doesn't soak up a lot of bandwidth, and those of you who've taken online courses know things don't always work out online, things lock up, servers go down. So that's just one of those things that just happens. And so if you lose that time, it becomes an issue. So in conclusion, what I found is really not too much of a difference in terms of whether it's online or it's a traditional lecture. And it's really getting back to what information is required to optimize the generalization techniques. Most students would like to have access to someone that can help them answer specific questions. So again, not going straight up to a text or kind of a video and you watch it. I really want someone there that can explain it if I do have a question. I think that's important from an educational standpoint anyway. And in terms of the grades, I didn't find any really shift in terms of the grades, whether on midterms, pretty much about the same, regardless if it was kind of online or delivered. But it's really, again, what's the content there, and it pretty much was consistent across the board. Again, I think there's some areas for future research in terms of what's that optimal mix between giving traditional lectures and also online and the blend of the two. So at this time, I'll entertain any questions anybody might have. All right.
What LMS are you guys using to deliver your classes? And so how are students going to access that online content?
What I do now is we have a server. So
Yeah,
so we actually have we stream everything over a server. So right now we have, students log in, we have our GIS program website, go to cartography course, and they pull the information from there. They can also download the information if they're going to be traveling, or they can VPN in as well. So that's how we kind of use the information.
I have one more then.
Okay, yeah, go ahead.
What are you going to do differently next time you teach this class because of this?
Here's one thing I found, and I try to do it today, is talk less. Really, I broke my lessons down to 15-minute blocks and give the salient information. I went through all my curriculum and found, you can get cheesy with slides and animations and things, but honestly, people don't care. It's like, tell me what I need to know, show me what's important, reinforce it, and move on. So I really got away from kind of the edutainment, so we called it, like putting jokes and things like that, and just teach people what they need to know, because again, the student said, I signed up for this class to learn cartography and how to make maps, so anything that takes away from that. So I really got rid of a lot of superfluous content in those classes and just boiled it down to what people needed to know, and gave them time to work on stuff and learn on their own. Yes? Yeah, actually, so one of the things that one of the question was, what tasks do I give the students in order to kind of enable collaboration, and so they can collaborate on that? Couple of things. So I give them a lab project that's coming up for this semester, where they build a topographic line map. So I team them together. They have to go out and pull in all the data. So some of the data I give them is kind of canned data. Other information they've got to actually data mine. And so they got to come up with their design project and how they're going to produce that. And then on the final project, although they're individual projects, I have them collaborate on ideas. So they can learn from the data mining portion that we teach them, or I teach them since I'm the only instructor this semester. They can share ideas and see what's working, because this is an interesting field that we're in, because it's very collaborative. I mean, there's all ideas you go on GitHub or any of the other sites. There's code, there's ideas, there's information. That's awesome. And so with that, I had to kind of be careful. I'll caveat it with kind of you don't want to cheat or pull other people's ideas. So we have to monitor that quite well, and they all document the information. And that's another thing I guess I've changed in terms of that is I don't look at using other people's ideas as kind of, plagiarism or anything like that. I actually see it as furthering the science, as long as it's done the right way and you document it. Because you show what other people have done and how do you expand that and extend it. And I think that lends itself a little more positively towards collaboration versus kind of the punitive way we tend to teach academic documentation is if you cheat, we're going to kick you out of the course. So I'm trying to get them to think more positively about sharing the information and that documentation is a good thing. So that's kind of two things I've changed.
All right, thanks to both of our presenters in this session. You guys did a great job.
All right, thanks a lot. See you tonight.